Assalamualaikum Dr. Hamzari. My name is Nur Eliza binti Nazri. My matrix number is 202751. So now I'm going to present about my second assignment, which is for the summary part. So the main feature in using Laplace transform is for differential equations is the fact that transforming the derivative result in an expression with no derivative. So Laplace transform is used on linear differential equations with constant coefficients changes a differential equation which can, in principle, be easily solved.
Hi and Assalamualaikum doctor. Today I'm gonna give an explanation about the assignment 1, which is the principle and application of Laplace transform. So before we start, let me introduce myself. My name is Muhammad Fazil Nur bin Abu Bakar and my matrix number is 203715 and I'm from group 4. So for my part, I will give an explanation about the objective of our assignment. So there are 4 main objectives of our assignment. The first one is to learn a simple way of solving a non-homogeneous differential equation. So before this, we have learned about how to solve a homogeneous equation using a lot of ways. But in order to solve a non-homogeneous equation, we have to use the Laplace transform. So the second one is to learn an application of Laplace transform in engineering analysis such as electrical circuit, computer science, and etc. And the third one is to learn a Laplace transform for ordinary derivative and partial derivatives of different orders. And the final one is to learn the use of the table of Laplace transform, inverse Laplace transform, and the convolution integral. That's all from me, doctor. Thank you.
Hello and Assalamualaikum. My name is Nur Faiza binti Kamarudin and my matrix number is 203736. So today I will present to you about the introduction of Laplace transform. So the Laplace transform was first used on 1910 by Batman, which is on 1920s was explored and codified by Dawes and was first the subject of a textbook as late as 1937. And however, during 1920s and 1930s, this topic was seen as a topic of frontline research, which is the application that caught upon it today were then treated by an older technique, the heaviside operational calculus. But then, it was rapidly displaced by the Laplace transform, and the exchange was virtually complete by 1950. So, what I can say is, Laplace transform give a very helpful technique that can solve problem more way easier, which literally transform the original differential equation into an elementary algebraic expression, which is Laplace transform. So, from this, let f be a function defined on a finite or infinite interval t a less than t and less than b, and let ks be a prescribed function of variable t and parameter s. Then this is called integral transform of f. So Laplace transform is one of the most simplest and the most useful from this transform, which is s is a complex variable. So we may solve differential equation by using Laplace transform. So to see how, we need to find an expression for L f bracket t by formal integration by part. So this is it.
Assalamualaikum and hi to Dr. Amzari. My name is Muhammad Azim bin Zulkifli. My matrix number is 203244. In this video, I will talk to you about the engineering application of Laplace transform. Laplace transform is widely used by electronic engineers to solve the electronic problem. Laplace transform can be used to solve quickly differential equations occurring in the analysis of electronic problems. In this video, I will show you one example on how to solve electronic circuits problem by using Laplace transform. The problem that we are going to solve is to determine the charge on the capacitor and the resulting current in the circuit at time t, given that R is equal to 160 ohm, L is equal to 1 Henry, C is equal to 10 to the power of 4 Fahrenheit, and ET is equal to 20 volt. In this slide, I will show you diagram of the circuit that we're going to solve. Okay, so now I will show you on how to solve the electronic circuit problem by using Laplace transform. First, you can use Kirchhoff's second law to the circuit given that we give you this equation, and you can use I equal to dq over dt that will give you that equation. After that, by substituting the given values for L, R, C, and ET that I mentioned you in our previous slide, will give you this equation. Next, by taking the Laplace transform throughout leads to the equation, it will give you this equation. And as we all know, Qs is the transform of Qt, and we are also given that Q0 is equal to 0 and Q0 equal to I0 equal to 0. So we can reduce our equation into this equation. And after that, we can rearrange our equation into this equation. And then we can resolve our equation into partial fraction. And our equation will become like this. And then to determine the charge of the circuit, we will be taking the inverse transform and making use of the shift theorem, and it will give you the charge. And then we can determine the resulting current in this equation, and I will show you the resulting current there. So that's all.
Assalamualaikum warahmatullahi wabarakatuh. And hi everyone, I'm Shukra Afifi bin Muhammad Arifin. My matrix number is 202794. Today I will explain and present to all of you about my group assignment 2, Laplace transform. My contribution for my group is application of Laplace transform in nuclear physics and also the conclusion for the whole task. For the application of Laplace transform, in nuclear physics, consider the following first-order linear differential equation. The equation is dn over dt equal to negative lambda n. This is our equation. And we can use the Laplace transform to solve this equation. So we rearrange the equations. Before this, dn over dt equal to negative lambda n. So we move lambda n at the left side. So dn over dt plus lambda n equal to 0. Taking Laplace transform on both sides, the equation is sln negative n 0 plus lambda ln equal to 0. We can change and arrange this equation to this equation by assuming ln equal to n bar and n0 equal to n naught. So the final equation that we get is n bar equal to n naught over s plus lambda. Now, taking inverse Laplace transform on both sides, we get nt equal to n naught e negative lambda t. So which is indeed the correct form for radioactive decay. For the next part, conclusion. Laplace transform is a powerful tool used in different areas of engineering, science, mathematics, and physics. With the ease of application of Laplace transform in many applications, many research software has made it possible to simulate the Laplace transform equations directly, which has made a good advancement in the research field. So, these equations can be typically solved using either analytical or numerical methods. Since equations having polynomials are easier to solve, we employ Laplace transform to make our conclusion easier. With the help of this method, the students are able to communicate mathematical ideas with their surroundings and for the future. They can apply their knowledge and understanding to mathematics in daily life. That's all from me. Thank you.